Hey there. We are going to dive into classes in C++, which is a precursor to one of the most important topics that you'll learn in the second programming workshop course, which is object-oriented programming. Objects are related to classes quite significantly, and what we're going to do in this exercise is just go through some of the most basic kind of objects out there, namely structures and classes. So in our first exercise, we're just going to make a structure. This structure that we're going to work with is a person, and so if I wanted to represent a person, well, doing it with a single variable is going to be very difficult, because if I just wanted to say my person is a string, well, it's going to be very complicated to have a string. I certainly cannot represent my person with a single number. That's definitely not going to have all of the versatility that I might need to represent everything that a person is. So to do so, I'm going to make a structure. We're also going to see what happens if I try to output a person, and it turns out it's not going to go too well. So to make a person, we'll get our usual suspects in here, and I'm going to say that I want a structure called person. And in my person structure, I'm going to have a first name, which is going to be a string, because that makes sense for a name. Similarly, last name would also be a string, because it's just a name. Age should be an integer, because it's a number. Is employed is either true or false. This should be a Boolean. And is student should also be a Boolean. Now, how do I create a person? There's a couple different ways that you can do it. One of them is to declare any initial versions of it, any instances of a person right after the braces. So I can say person1, for instance. And now person1 is my person located at this memory address. So outputting a person like this is, fine and good. Tells me that there's a person there. I can't really dereference this though, because this isn't a pointer, right? This is just the location in memory where all this data is being stored. And I certainly can't do something like this, because the computer has no understanding of what it means to send a person to C out. So right now, I don't really have a good way to output the properties of a person, or in fact, we haven't even gone over how to set them. But right now, what we do have is a location in memory where person1 has been set up. Similarly, I can make a second person, person p2, and now that's in a separate spot in memory. And you can do the math and see that basically the difference between this memory address and this memory address here is pretty much how much space is actually needed to represent this person in memory. So let's move on to the next one. Now that we have our person, let's write a function that takes 5 parameters and returns a person from them. And we'll call this from our main function and print out each of the attributes. So this is our exercise 1. We're going to duplicate it into exercise 2. Here we go. Write a function, call this function. Okay, so I have my person. Let's clear some of this stuff out. Now, if our function returns a person, then it should return a person. And we'll call it makePerson, because that's what our function is going to do. And it's going to take a string first name, a string last name, an integer age, and a Boolean is employed, and a Boolean is student. And so what I'm going to do is I'm going to say, okay, person P, this is my new person, P dot first name is the first name in my parameter. I'm going to do the same thing for, all of my parameters that are here. So their last name, age, their employment status, and their student status are all going to come from each of these respective parameters. Age, is employed, is student. Boom, done. I have to make sure I run all my code from start to finish. And I probably should return my person. There we go. Okay. So now I can say person P equals make person, and I can say make myself. Why not? True, false. Boom. And now P is again the address where everything is, but if I want to actually show the values that are in here, I can say, you know, p dot first name, there's Michael, my last name, and so on. If I want to see the whole thing, I can say output the person p dot first name, p dot last name. Oops. Oh, let's add a space in here. Is age years old. Then I can say this person is, and then here's a neat little trick, which is called the ternary operator, which allows me to do something like this. If I am employed, I want to say that I am employed. And if I'm not employed, I want to say I'm not employed. So what I'm going to do is ask the question, am I employed? P dot is employed, question mark. I'm asking the question, is this person employed? If so, I don't want to say not employed. But if they are not employed, I want to say not. Employed. I'll pause here just to show you what this looks like. It's a p.h. And years old. This should be fine. You're in this again. There we go. The person, my name is 34 years old, and this person is employed. I think I have an extra space hanging out here. There we go. Let's fix that. And now if instead of being employed, I'm suddenly not employed, you will see that the code changes from the person is employed to the person is not employed, which is kind of convenient. And I can do the same thing with a student. Say is student. And similarly, if I switch this to true and true, run it, and hooray. So this weird looking thing here, just so that you see exactly what's going on here, requires you to put a Boolean expression before the question mark. You're literally asking a question. Are they a student? Are they employed? Or any other Boolean expression that you want to have that evaluates to true or false. If it is true, the value of everything here in parentheses is evaluated as whatever is right after the question mark. So in this case, I want an empty string. I don't want to put anything there. If either of these is false, the value evaluates to the word not, which allows me to, if I am not employed, to write not employed as opposed to employed. Okay, and that's everything that we had to do. Great, we can move on to the next one. Okay. Continuing, let's make a pointer that points to a person and see what happens. Duplicate. Okay, so let's say that I have my person down here and I want to point to that person. Well, I need a person pointer. Say person pointer, PTR, is the address of my person. And let's say I do star PTR dot age. So what it says here is an interesting message. This thing is a pointer. Did you mean to use this arrow right here? And so what's happening is because pointer is a pointer, rather than dereferencing it to get the person and then get the age, which you can do, you can actually just do something like this if you really want to and it'll work fine. This is kind of ugly. What you can actually do to make it a little bit more elegant is PTR arrow age. And so this arrow is a shorthand to mean whatever structure, class, object, or anything that this is pointing to, grab the attribute from it, which is the age. And you can do this with any other thing too. You can do it with the first name, and so on and so forth. But you have to use this arrow if you are using a pointer. Similarly, I can dynamically make a new person rather than using P, so I can say something like person star PTR2 is a new person. And then the person at PTR2 is, let's make another person. Who's a nice person that I can make? Let's go with my good friend Randy. We're gonna pretend that he's 35 even though he's not. And I can say PTR2 arrow last name. There we go. So here I'm dynamically making a person, making a pointer point to it. I need to assign that to be a person. I need to actually put the data inside of that. And then now I have a last name. If I want to, I can also just manually assign these one at a time, but I would like to set up all of the attributes so I don't have anything that's blank. Okay, so short exercise, but nice to show that pointers interact a little bit differently when it comes to accessing attributes as opposed to non-pointer variables. Okay, for our last exercise, we're going to work with an actual class. So we're going to change the person structure into a person class. And we're going to add a member function. The member function is going to set the person to be unemployed if their age is below 16 or above 65. So taking this, duplicating it, we are going to change our person structure into a person class. So I just say class. However, I also need to indicate that all of this information is public. If this information is not public, I'm not able to access it. And I think that's enough to get everything else to go okay. I shouldn't have any errors or anything like that, which is good. But if you forgot to include this public, you will notice that there are errors, and I'll just show them so you can see. And they kind of come all over the place. But they all say private, 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 private. And that's because the default behavior for classes is that things are private and you can't use them, which is not very helpful a lot of the time. We'll learn a bit later on why you might want to make things private, but for this course, most of what we're going to be doing is relying on publicly available information, which means we need to write the word public at the top of our class. Now that I have a public class that has this information, I also can add a member function to it, and I can call that member function void set employment, and it takes no parameters. You have two options for implementing this. One of them is to implement it right here, which you can do. You can actually say instead of a semicolon, just open the braces and start writing the code. And that's totally fine. However, it's generally considered good practice, especially when you're writing longer functions, to have it in a separate location. And in order to do so, I need to say my function void set employment isn't just some random function in kind of the middle of nowhere. It actually belongs to this person class. And to indicate that, I need to say person set employment. And here I'm going to say if their age is less than 16 or their age is greater than 65, then is employed equals false. And so now let's say I set myself to be 15 years old, go back in time perhaps. Let's run all my code, make sure everything is going okay. Now I can say p dot set employment, and then we'll output this code again. Oop. And now I've gone from being employed to being not employed. In the function you see here, I've used the same names as the variables that belong to the person class. However, you don't necessarily want to write it like this because this can be ambiguous. Rather than writing it like this, a recommendation that you might consider is to instead specify that these ages and this is employed belongs to the person calling this function, which means it's this person's age this person's age, this person's is employed status. There is no significant difference between the two things that I've written here, except to make it very clear that this age variable is not a global variable. It's not part of some other function, part of some other class. It belongs to the person that is involved. The word this, you can see is a special keyword, and what it literally is a pointer to the person for whom this function belongs. And of course, we saw from the previous exercise, you need to use an arrow to access the attributes of a pointer, of a class that a pointer is pointing to. So this is optional. It's not necessary to include this, but you will see this quite often, so it's good to have it just for clarity's sake. And that wraps up our exercises for this lecture. Feel free to check out the next set, which are already up there, so you should be able to see them right away. And I look forward to seeing you in class. Bye-bye.